Hello, welcome to our today's lesson where we shall be looking at the introduction to programming. I'm the one to present, that is Kalora Richard. The first thing we are going to look at or to learn is the elementary programming principles, and we shall start with the definition of terms as used in programming. The first term we are going to look at is a program. A program is an organized sequence of statements, or what we call instructions, that when executed they cause the computer to carry out an defined task. So a program is an organized sequence of instructions or the statements, and when these instructions are executed, they cause a computer to perform a defined task. The next term is a programmer, and the programmer is a person who writes a computer program. The programmer is a person who writes a computer program, and in this case this person should be using a particular programming language. He or she should be conversant with a particular programming language and use that programming language to program or to write a computer program. Then the other term we are going to look at is a programming, and the programming is a process of developing a computer program, or a process whereby you use a particular programming language in order to solve a particular task. We have a source code or a source program. Source code or a source program is any program that has not yet been translated into machine readable form. Any program or codes, all we call them the texts that are written in a particular programming language and they have not yet been converted into or translated into machine readable form. Then object code refers to any program that is in machine readable form that has already been translated into machine readable form. We have the system software. System software can be defined as a collection of programs which assist with the program development. System software is a collection of programs which assist with program development and the execution of the program. Types of system software. We have three different types of system software. We have the language translators, we have the loaders, we have the linkers. We shall go one by one. We shall go on to one by one. We have the language translators, we have loaders and linkers. So we shall be looking into them one by one. So we have types of translators. Or when you start with the translator, language translators, we have language translators, and we say first on the language translators, we say the language translators they are, we have the types on the same, where we have the first type being the assemblers. They convert all this translate assembly language into machine language. We shall come to assembly language in just another topic in our today's lesson. We have the compilers. Compilers, they translate the entire source code into object code, and that's to underline the word entire. They translate the entire source code into object code. Then interpreters, they translate the high-level programming language line by line into machine language. The interpreters, they translate the high-level language line by line, can say line by line or instruction by instruction. And in this case, line by line means that if it defines a bug, or what we call a mistake, it will first prompt the user to correct the mistake before the translation is completed. Then when we speak of the assemblers, that is compilers and interpreters, we have the comparison, why the compiler and why interpretation. So when we speak of compiler, the difference between a compiler and an interpreter is that a compiler will translate the entire source code, while an interpreter will translate the code line by line, or what we call instruction by instruction at a time. So when we speak of compilers, the object code is always produced by the whole source code, while in interpretation the short object codes are produced and are not retained. Then we say that in compilers the program needs to be translated only once, but when it comes to interpreters, the program will be translated each time it is executed. So compilers use short execution time, while interpreters have a longer execution times. When you speak of compilers, they have more sophisticated, that is, they are more sophisticated since it deals with the whole source code. The interpreter are simpler and easier to use. Compilers will require more memory for translation of the source code, while interpreters will require less memory. When you come to, remember we were dealing with the types of system software, we have gone to language translators and we have seen the types of language translators. Then when it comes to loaders, a loader is a program which accepts the object code, prepares these programs for execution and initiates the execution. So a loader is a program which will accept the object code, prepare these programs for execution, and also initiate the execution process. A linker is a program that combines separate modules of a machine code before execution and after compilation, and this is done by planting the appropriate addresses in all the call and return instructions so that all the modules are linked together properly. Remember, when you are making a program or when you are coding, you have a separate codes, or what we call separate modules, and these modules, as you are trying to link them together, a linker will be able to combine these separate modules. You combine them into one continuous source code, and then it will enable the linking between the call instructions and the return instructions. We shall be able to see how this is linked as we continue with the programming process. I would like us now to go and look at the levels of programming languages. The levels of programming language. In short, we have only 2 levels of programming languages, and inside the levels they are further classified into what we call generations. So the first is the low-level language, all the low-level languages, and these were during the 1950s. The low-level languages, the computer can directly understand them, and they require less effort to translate. They require very less effort to translate. Remember, computer works with the binary digits, which are the zeros and ones. So this 0 and 1 are what we call the binary, and in this case the first low-level programming language, or the first generation, is what we call the machine language, and the machine language uses the binary logic, which are the zeros and ones, and machine language runs only on a computer for which it was developed. Thus, we refer to this as machine dependent. It can only run on that particular machine where it was created. Advantages. So the advantage of this machine language is that no transition is needed and they require very less memory, since they are already using the machine language. You have the assembly. Okay, before we go to the assembly language, you can also see the disadvantages of this machine language. The disadvantage is that they are not portable. Portability means that you can be able to carry or to copy the software and install it in another computer, and in this case they are not portable since they are machine dependent. The other thing, the coding is tedious and time consuming, and in this case when you are coding using binary logic, it may be very tedious, may be very time consuming, and also this brings us into another disadvantage where we can say that they are not user friendly, because while you are trying to write a code using zeros and ones or the binary logic, it may be very lengthy and sometimes very boring. You can also say that the other disadvantage is that debugging using the machine language is very difficult. Now, the assembly language or the second generation programming languages, in this case, we say the instructions are written using meaningful abbreviations for programming instructions, and these symbolic instruction codes, we usually say they use what we call mnemonics or the symbolic instruction codes. Examples are something like MOF for move, SUB for subtract. Can also use as many as possible, and advantages of this is that, okay, when we start converting assembly language to machine language, that is where the assembler comes in. When we were speaking or we are dealing with the types of language processors or language translators, we saw something to do with the assembler, and the assembler will be able to convert the assembly language into machine language. The advantages of this is that with the assembly language, a programmer will write a code, and this code can be converted into zeros and ones only into machine readable format. It has a closer control of the computer hardware and execution. That's also another disadvantage. That is another advantage. Then disadvantage is that it must be translated, so you have to use an assembler to translate, and designed for specific machine. That is also machine dependent. And you can also say that they are very difficult to debug. So in general, when we speak of low-level programming languages, can speak the advantages in general, and we say they are stable and anti-crash. They require less memory. They do not require translation except for the assembly language, where you translate it into machine language using an assembler. And you can also say they are very efficient, making optimum use of both computer memory and the processing time. The disadvantages in this case, they are difficult to learn and work with, and they are also machine dependent. The programs are very long, thus they take long time to program or to make the program. They are very difficult to debug. The debugging is removing of mistakes where you have made a mistake or where you have programmed wrongly. They are difficult to maintain. Maintenance is in case the program requires updating, things to do with the refreshing. They'll be very much difficult when using the programs that are coded using the low level programming languages. In the low level programming languages, we have seen the first generation and the second generation. First generation being the machine language, the second generation being the assembly language. Now let's come to the high-level programming languages. They were between 1956 to 1963 when Kenya was getting our independence. That is when the high-level programming languages were developed. Instructions are written as a series of English-like statements, and they can be understood by people who are not very much experts in programming. And we say that they are machine independent. You can say that high-level programming languages are machine independent, meaning that you can be able to code one program and be able to install it into different machines. That is the meaning of machine independent, meaning that if you code one program, you can be able to place it or install it into different machines, the way we do with the WhatsApp programs, where you can be able to download it and even to be able to install in more than one mobile phones. Categories of high-level programming languages. We have the third generation, which we call them the TGLS, or the structured programming languages. The structured programming languages, we also refer to them as procedural. Procedural meaning that a programmer can write different modules or different procedures and make it possible to break the program into components, and these components, we call them modules, and each module will be able to perform its own task, and later you consolidate all these modules into one program. That is the meaning of procedural language. It will make it possible to break the program into components, smaller components, which we call them the modules, and each module will perform its own task, but at later they will all be consolidated into one continuous program. Examples of third generation programming languages include the Fortran or the Formula Translator. We have the COBOL, the Common Business Oriented Language. We have the BASIC. BASIC stands for Beginners All-Purpose Symbolic Instruction Code. We have Pascal. Pascal was developed by a French mathematician known as Blaise Pascal. We have the C. C is used to develop system software such as operating system. It's very stable and it can camouflage. It can camouflage as both the high level and the low level, so it will bridge that gap of high level programming language and the low level programming language. We have ADA, another example of that generation languages. We have ADA. ADA is suitable for developing military, industrial, and real-time systems. And in this case, in our course, or in this diploma in ICT, we shall be able to look at C programming language and also Pascal. The advantages of these third generation programming languages, or the structured programming languages, is that they are easy to read and modify. So very easy. We shall see how easy it is. As we continue, we shall come to a place where we can be able to code using the C or the Pascal. They are machine independent. I think we have also stated that is, we can be able to copy them to other machines. The fourth generation languages, or the 4GLS, they were developed in mid-1970s, and they are more user friendly. That is, easy to learn and use than the 4GLS. So the more the generation continues, the more easier they become. And you say they are non-procedural. The language syntax, or the grammar, is natural, almost pure English. We say near. It's not pure English, but it's near English, and we use menus to guide the user. Examples in this case, we have the Visual Basic, we have the Delphi, Pascal, Visual COBOL, the C++, DC. Then the fifth generation languages, or the natural languages, we say that they are designed around the concept of solving the problem by enabling the computer to depict or to imitate a human-like intelligence. So in this case, you give the computer the problem and the computer solves the program instead of the programmer spending a lot of time to come up with the solution. So in this case, it's the program, it's the computer, or it's the language that will solve the problem for you. I have said, as we continue increasing in the nature or all the generation of languages, the more easier they become. So the 5GLS are associated with expert system and artificial intelligence, and these systems are popular in medical fields, but are not widely used in business applications. Examples of 4GLS, that is the 5GLS, you have the Prolog, or the programming language, you have the Lisp, you have the Arkham and Mercury. We have another type of programming languages we call the object-oriented programming languages, which we call them the OOP. And we say with the object-oriented approach, the programmer can package the data and the program, all the procedure, into a single unit called an object. When you speak of an object, it's an item that can contain both data and procedures that read or manipulate data. The OOP will be able to allow inheritance, polymorphism, and also encapsulation and data abstraction in its use. We shall come to object-oriented programming languages as we continue with programming, where we shall be able to see how to create inheritance, or the ability, inheritance being the ability to acquire a trait or behavior or a characteristics from an existing entity. Examples of the OOP, you have Java, Similar, Smalltalk, etc. You have as many as possible. So when you come across others, don't be limited to this. We have the web scripting languages. Examples, so that is web scripting languages. They are they are languages that are used to create or add additional functions on web pages. And examples are hypertext markup language, and the hypertext markup language has specific syntax rule for defining placement and format of text, graphics, videos, and sounds on a web page. And in this case, HTML uses tags, simple tags that you can be able to format or enable placement of this graphic or videos onto a web page. We have the advantages of high-level programming languages. The advantages of high-level programming languages, and say they are portable, meaning that you can be able to code one program and be able to install it into more than one machines. They are user-friendly, that is, they are easy to learn and use. They are easy to debug, you can be able to remove all, you can be able to correct the mistakes using high-level programming language. They require less time to code. And they provide better documentation since they use English statements. Disadvantages: when you speak of disadvantages of these high-level programming languages, you say program execution is slow, since they can be interpreted. Since they have to be interpreted or be converted from from object code to machine readable form, that is being converted from source code to machine readable form, and they also require large memory for execution. With that, I'm grateful for your time. Next time we shall be able to see the program development process.